Yeah. All right, we're here. Hello, everybody. Welcome to the Cosplay for Science Theater, our very first watch party as we dissect or, break down the DNA of Star Wars Episode 4, A New Hope. For those of you who have never heard of us before, we are Cosplay for Science. We are a group of scientists and educators who do our best to help people understand the science in their everyday lives and interests, whether that be Star Wars, Pokemon, or anything that, it's just really fun. We find the science in there and help you appreciate it. So let's introduce ourselves. My name is Gabriel Santos. I am one of the co-founders of Cosplay for Science. I am a paleontologist and educator at the Alf Museum of Paleontology. I do a little bit of fossil stuff. I do some geology things. So I'm going to be helping talk a little bit about like geology and kind of like the planets for today. Maybe a little bit of biology. I have a background in biology. But yeah, that's kind of what I'll be helping with today. What about you, Sarah?
Hi, everyone. I'm Sarah. I'm a PhD candidate at Northwestern University, and I study teaching and learning. I also do a lot of science outreach, just about the science of Disney, and Star Wars falls into that. So I've become more and more of a Star Wars fan over the past few years. I'm really excited to watch this movie and share all of the cool things that I like about it from a whole bunch of different aspects of science. I'm a social scientist, so I might have a little bit more of that background and perspective today, but I'm excited to chat with you all and answer some questions.
Awesome. Sophia, welcome to our live stream today.
Hi, everybody. Yeah, well, thanks for having me. I'm a PhD candidate at the University of California, Irvine. I study cosmology, and particularly I focus on dark matter, dark force. And so I'm really happy to be here. Excited to talk about the science of Star Wars with you all and just geek out.
Awesome. Also, I'm a fellow anteater myself, so Zot.
Oh! What? Wow, that's great. That's awesome. Cool. Zot. That's awesome. I had no idea.
That was my undergrad. I keep forgetting sometimes. So.
Yeah.
All right.
I love the school, but yeah.
I loved it too. It was a great place. That's where I got all my bio knowledge.
Yeah.
Oh, before last but not least, we've got Reno here today. Say hi, Reno.
Hey everyone. My name is Reno. As was said, I studied paleontology at the University of California, Santa Barbara. So go UCs. Though I'm a gaucho, not a zotter, not an anteater. Sorry about that. And yeah, I studied paleontology at the College of Creative Studies at UCSB. Currently, I'm a new member at Cosplay for Science, and I hope to eventually work in museum science. But museums are all closed right now, so I've decided to put my creative output into other ventures, including this, as well as music and acting and other performances. And I'm very excited to be here today, and I will be moderating the chat. So if you have any questions, please feel free to ask them. I'll try to make sure that we can get to some of them. But keep everything respectful and relevant, please. But please do ask questions.
Yeah, if anyone has anything, type them in the chat. We'll do our best to get to them throughout the stream today. So just a few things for Cosplay for Science Theater. We will not be able to show the movie on the live stream or any clips. So in the bottom of the screen, I have the time code, so you can sync up your movie, whatever device you're on with us, so that you can follow along and kind of keep track of what we're doing. And what we will be doing, like I said, is we are all scientists and we are all Star Wars fans, and we will be talking about the amazing science that inspired a galaxy far, far away, and even some of the science that a galaxy far, far away inspired back here on Earth. So it should be really fun. We'll try our best to get to as many questions as we can, but overall, it's just going to be a fun day today of geeking out about science and Star Wars. Really quick, before we get started, let's all kind of just go around and talk about how we fell into Star Wars, and has it affected the way that you think about science or your love of science? Sarah?
It's a good question. Yeah, so I think my earliest Star Wars memory is going and seeing Episode 1 in theaters. Like, there was a line wrapped around the theater. I went with my dad, and we went and got burritos because the line was so long and we didn't want to wait outside in the heat. But I think watching pod racing. I was like, this is the coolest thing ever. So I got really interested in it then. And I don't know if I think it's inspired my critique of like learning in a lot of ways, because I think the Jedi way of teaching and training other Padawans has a lot of parallels in some other models of teaching and learning, which I find really interesting, and I think could be helpful for learning things in the future. But other than that, I just think the robots and the special effects are super cool, and seeing how much CGI has changed over time has been really awesome. And I also particularly love all of the strong female characters throughout the movies and TV shows. And yeah, I think that's probably one of my favorite parts.
Awesome. Speaking of, who are you cosplaying as today?
Oh, I'm cosplaying my best as Jyn Erso. Kind of threw it together today. Rogue One is my favorite Star Wars movie. And my fun fact about my cosplay, I guess, is that her nickname is Stardust. That becomes very important in the movie. And all humans are made of stardust. We are made of the same chemical elements as stars, and that passed through billions and billions of years to make humans. So I think that's really awesome.
I love that. Sophia, how has Star Wars like affected you? You are our resident space expert today, so I'm really excited to like ask you some questions.
Yeah. So my story is that like I have a pretty cool older brother, and so all the stuff that I was introduced to as a kid was because I was surrounded by it because of him, and so I watched it when I was a kid, and I've just loved it ever since. I love anything that goes on in space and whatnot. That being said, I didn't know from childhood that I wanted to do space for a living. It's just that I love the stuff, and so instead of coming in cosplaying, I brought my friend Grogu.
Yeah.
I have a little Darth Vader toy.
Gotta have Baby Yoda. That's a good sign for today, I think.
Yeah.
Reno, how about you?
Well, you could say I'm a bit of a Star Wars fan, just a bit. That would be an understatement. I followed Star Wars since I was just a wee babe, and I've always been enraptured by it. I really appreciate the storytelling in it, and I think that influenced me in ways that were subtler than I could have even imagined until now. Because even when I was studying paleontology, I really liked. I always envisioned when I was studying evolution. To me, it's a story. It's an anthology, but it's also it has a lot of little details that you can nitpick. Talking about the tree of life, just like Star Wars. Star Wars is a treasure trove of nitpicks. In fact, the whole fandom could really be boiled down into just a set of people who really like to nitpick. And I love recreational nitpicking, as long as it's not too, in people's faces. I love recreational nitpicking. So that's why I appreciate the chance to join in today. I know a lot about Star Wars. I really enjoyed, I did a little reading up beforehand, and I really enjoyed knowing that there's even so much more to learn about Star Wars that you can apply to real life. And I will be offering some links in the chat if to answer some questions, or if we talk about stuff, I'll offer some further readings, some of which you could ignore it if you don't care, but there's different kinds of canonicity now with the Star Wars franchise, so I will put what canon, if anything falls under one or the other, I will put what it is, just for clarity's sake and for nitpicking's sake. And today I am cosplaying as Luke Skywalker from Empire Strikes Back when he goes to save his friends on Cloud City and fights, spoiler alert, he fights his father.
Spoilers!
I'm sorry,
on.
I shouldn't have said it. I'm very I actually did not, this is not my costume, this is not my cosplay. I have a friend who goes to cons a lot, and this is an old costume of his. That he was nice enough to let me borrow, that he made actually, and he wore it for Halloween once when he's one of my dad's friends, and I dressed up as Darth Vader when I was maybe 8 or 9 years old, and he was Luke Skywalker, so for that Halloween I was his father. And today the father has become the son. All right.
Awesome. Thanks, Reno. For me, Star Wars is life, like here's paleontology. Star Wars is like up here for me. That's how much I love Star Wars. Like it's really influenced a lot of like for you, Sarah, it's influenced how you're a teacher, right? For me, I love storytelling, and Star Wars is one of those stories that really just like taught me how and inspired me to be a storyteller. And not just, for like stories in traditional sense, but even in the way I teach and talk about science, because there's so many cool things in Star Wars that have inspired my curiosity, my the way I think about the world, and like with the Force, how they always talk about how everything is connected. When you're a paleontologist, you kind of see that through deep time. And there are so many other things that have interested me. A fun fact, even, Sophia, when I applied for UC Irvine, I wrote about the first time I wrote Star Wars Episode 5 in my entrance essay, and I still got in somehow. So.
What? That's awesome. Bonus points for UCI.
Right? I'm just saying.
Hey, I mean, if that's an acceptance point, that's pretty cool, in my opinion.
Well, my teacher was like, find a way to stand out from all the other essays, and I was like, all right, cool. I'll talk about Star Wars and how it inspired my love of science, and I'm really happy that they let me in, because that eventually led me to being to do a live stream with a bunch of amazing scientists to talk about science of Star Wars.
Nice.
Full circle. There you go.
Full circle. All right, so who's ready to watch this movie? Everybody? Yeah. All right, cool. So, like we said, we will not be able to show the movie or any clips, because, copyrights and stuff. But you can sync along your live stream with us, your stream with us, and I'll have the time code in the bottom corner of the screen right now, so you can follow along. Are you ready, Sarah?
Yeah. Should I count down?
All right, here we go. All right. So we'll start the movie in 5, 4, 3, 2, 1. All right, here we go. I will say that I absolutely love just the music. I mean, it's not super sciencey related, but I love every single bit of the music of intro for Star Wars. There's just something about it that just makes me, I don't know, it gives me a huge dose of serotonin.
Oh, yeah.
As a musician, I had there's a lot that I can point out about that. John Williams' score was very brilliant in the way that he uses motifs and themes. Though some say it is a little derivative. If you listen to Gustav Holst's The Planet Symphony, you'll hear a lot of influence that John Williams took from that symphony.
Wow.
I think that's clever.
I use this as my background music a lot in when I do my TikToks.
Awesome.
I talk about dark matter but the type of dark matter that has dark forces, so it's like it just makes total sense. The dark. Yeah.
Sophia, I will say I love all your TikToks, so I think they're fantastic. If you haven't followed yet, follow on TikTok, Astropartigirl. Also, I love your handle too, by the way.
Thank you. Oh no, I was just really happy that you pronounced it right. Usually people say Astropartigirl, and I'm like, oh, it's like particle, astroparticle, like, and then mash up with a girl, right? So thanks. Yes.
All right, so here we are, the iconic. What is this thing called?
Scroll.
Opening crawl.
Yeah. Opening crawl. That's what it is. It's been kind of a long day now. I also had like a bunch of ice cream before we started, which I slightly regret right now. But anyway. So, yeah, getting right into it, Sophia. We start, in space. We've got spaceships, we've got lasers, and just all the basic elements of science fiction, or in this case, science fantasy. For you, when you watch these kind of things, how close are we to getting these kind of things, could you say, or seeing these things in real life?
Not.
Okay.
We're not. So, you in Star Wars, you see like just the travel alone. It's faster than light, but they use hyperdrive rather than faster travel. But they are traveling. So that's definitely not possible. At least right now, there are ways that you can at least sort of theoretically have an idea of how to do it, but whether it's actually going to be not sure. Also, yeah, so like see that, how you can hear all that stuff, you'd hear nothing in space. It would not be that exciting because there's no sound in space, so you would not hear things exploding at all. Mm-hmm. So there's like it's we're not even.
Okay, that's fair. I mean, it is science fantasy, right? This is, for me, I think there's a lot space fantasy. There's a lot when people will talk about things and they're like, that's so fictional. But I think when it comes to science or space fantasy, there's the line between grounded in reality and believability, and Star Wars somehow creates this real believable galaxy and with their own physics, I would say. Is that like a good way of saying it, where they kind of play by their own rules in that galaxy, right?
Yeah, and in general, also like you have to like it's still Hollywood, and so you have to add this aspect of excitement. Like it would totally not be exciting to watch a space fight that you can hear nothing. You know, of course, on the inside of the ship, you would hear stuff like stuff breaks, then you would hear that. But it's like it would just not be exciting to like watch something from from space and kind of just see like nothing happening. There's no sounds at all and stuff. So there's always the Hollywood aspect of it, and I mean, it's fun. And it's not stuff that just kind of comes out of nowhere. Like it's, as I said, there is theory behind ways that we can travel faster than light, and or rather, not really travel faster than light, but like achieve that. So like wormholes and stuff like that. So it's not just pop out of nowhere type of stuff. And I think it's really exciting to be able to watch it and watch it now, because we're probably not going to be able to see a lot of this stuff ever. And so why not, right?
I think the artificial gravity in all these spaceships is very interesting.
Yeah, so actually that's the one thing I feel like, and without that it would just, again, it wouldn't be as exciting. Like I don't know if any of you watch The Expanse, but The Expanse is pretty good with how it would with how things would play out if you were like accelerating and stuff like that. Like they have these like magnetic boots that they got to turn on and all that. Whereas here it's just like you got artificial gravity, everybody's just walking around. It's like not a problem. But I mean, the stuff that you see, I feel like you kind of need this. So yeah.
Yeah, to make it feasible as a movie.
And I think for the time too, when the movie came out, like there's no way they're gonna like try to create like people floating through these spaceships and things like that. It was just like practical, but again, it's believable.
Yeah, and I guess like also, I mean, it's not the storyline isn't really centered on that, and so I don't know what it would do for it. Whereas like The Expanse kind of makes sense to play that out, but yeah.
Sweet. I now that you mentioned The Expanse, I kind of want to do a watch of that one, because I kind of sidetracked, but I love that show. I haven't finished season 4 yet, but it's so good.
Yeah, actually, I'm on season 4 as well.
Okay, cool. If you haven't watched it, it's an awesome show. It's much more grounded in reality, you'd say, right, Sophia?
Much more.
Okay. Cool.
Much more.
And now here we are with the iconic. Oh. I'm hearing myself echo. Hold on. One second. Okay.
That might have been.
Okay.
I plugged my headphones by accident.
That's okay. I was just thinking if I was hearing myself through the Force again. I don't want that to happen this time. Well, we were on the iconic scene. We were seeing Princess Leia be awesome on the ship. One of the things that I've always wanted to know about. I mean, I can understand how it works, like biologically, but there a lot of the lasers that they have when like they have the stun or like just shooting them, like we don't even have all of the lasers we have these days are like just a single beam. Like we don't have anything that can shoot or whatever. Do you know a little bit about like how lasers work? Or is that part of like what you have researched a little bit, Sophia?
Not in terms of like my research. I've used them in undergrad for like for labs and stuff like that. But one thing that I can say is there are definitely lasers that are powerful enough to like burn your skin and stuff like that, and burn through a lot of different types of materials. So there's that. But like in terms of like shooting out lasers in that way, no, I don't think so.
Not yet, anyways.
Yeah.
So something that I thought would be interesting to mention is the way that apparently in the universe that blasters create the laser, and apparently it has to do with the ionization of Tabana gas that serves as the the ammunition, the gas itself. Tabana gas is actually mined in several places, including on Bespin, where Cloud City is. But Tabana gas is ionized, and the energy from that is sent into parallel lines through collimating materials through the barrel of the blaster. And you can the longer the barrel of the blaster, the more collimating material, the farther the range apparently of the blaster bolt, the farther it can go before it dissipates. Obviously, I don't think we're anywhere close to having anything like that. But do you have any more thoughts on that? Does anyone have any thoughts on
I'm
how
curious what collimating material is. I've never heard that word, so I want to learn.
I learned about it recently. It's something that keeps I think it keeps rays in a straight line. It's like it keeps electrons in a straight line. Yes. Okay.
Oh, it makes it into a column. Kind of.
Yeah, exactly. So it's all like kind of like focused rather than scattered outward. Yeah. Yeah.
Cool.
So a lot to fit into one little gun.
It's not like a Mass Effect where like they have the heat sink so that they're shooting tiny little particles of metal with their Mass Effect stuff on there. Okay,
is we're on the Crate Dragon.
Yeah, we're on Tatooine now. I was just gonna say, so I'm a paleontologist. I love all parts on Tatooine, especially this part because we're seeing a crate dragon. So in for those of you who've seen The Mandalorian, you've seen the greater crate dragon, which is gigantic. I don't know if it's canon anymore, but in the previous canon, there was the great crate dragon, the canyon crate dragon, and the lesser crate dragon, and there were smaller. This one, I think, in the original canon was one of the lesser crate dragons, but in the movie they're using a dinosaur skeleton, a replica that was actually left there, and I think you can still visit it today. Do you know, Reno?
If you can visit that skeleton?
Yeah, I think it's still there.
Well, they did film this in Tunisia, and a lot of the dome houses that we will see, spoilers, are real places. There were real dwellings, and those are popular tourist sites. I don't know anything about the fate of the prop of the skeleton.
I'll have to look that up, but it's definitely still there. I mean, it's definitely a dinosaur fossil, and it's just what I remember when I was a kid. I was, like a lot of young kids, I was totally into dinosaurs, and I saw that, and I was just like amazed and excited to see something like that in like Star Wars, and I had to go back and try to figure out kind of what it was. And so I spent like a few weeks going through like all of the dinosaur books I had, just kind of like comparing what that skeleton was to like any kind of dinosaur that I had in the book. And eventually I came across sauropod. But then when I got older and became a paleontologist, a good friend of mine, Matt Weddle, who is also a paleontologist who studies sauropods, told me what type of dinosaur that was. And actually I'm blanking what it is right now. Crud.
Probably it looks like a sauropod of some kind. But
yeah, it's a sauropod. I think it's a diplodocus or something like that, which is one of the long-necked dinosaurs.
I never remember seeing it have feet. I always just remember it like the neck part. So I imagine sauropods with feet. But that's interesting.
Because like the crate dragon in Mandalorian, we never saw its feet. It's just like a giant sand snake kind of.
Yeah. Oh, they did. They definitely changed the design of it for that show.
Yeah. One of the first great images of the crate dragon was Terrell Whitlatch's book, the the Ecology of Star Wars, which if you've never seen, please check out. That's an amazing, amazing book. But that's where I saw, I think, a full-scale crate dragon for the very first time.
I was gonna say with all the sand, it looks like it's very loose sand. We're getting to paleo talk now. Would I guess this is kind of almost archaeological talk, but would that not already have been buried at that point with this? Because it's sort of just laying on the top of the dune. Would the skeleton not at that point already have been buried because of wind pulling the sand over the body?
Well, in geology, like on sand and like sand dunes that that's really windy, you've got this thing called an aeolian environment. Right. So it's basically where the sand or the wind pushes the sand around, and like definitely on a sand dune, like it can push over and cover it. But I think depending on like the amount of the amount of sand like deposition that happens, it might take a while for it to actually get fully covered. And on Tatooine, it's like super super dry also, so like that skeleton's just gonna desiccate and it's not gonna break
Right.
apart very much. And depending on the actual size of it, it probably would just get stuck there and eventually buried. But
that would
also,
be a good place for preserving a fossil, correct? Because it gets covered quickly, so it's in an anoxic environment. It's incredibly dry, so we wouldn't have as much decay. And over millions of years, the sand would become sandstone, and then we would have it. It makes me think of the fighting dinosaurs from the Gobi Desert, which is a very famous fossil find of a velociraptor locked in battle with the Protoceratops, and they must have been just covered immediately with this a sand dune collapsing, sort of like an avalanche mode of sand, and they are preserved in such a way that you could tell that they were locked in combat.
Yeah, I love that fossil. I went to Mongolia a couple years ago as part of an educational trip, and parts of the Gobi look just like Tatooine. And I was standing out there for a while, and I was like, I really wish I had my cosplay right now so I could do a photo shoot out there.
That would be I'm gonna put some links in the chat to the fighting dinosaurs because that's just such a cool thing. This is probably the only time we're gonna be able to talk about paleo on this part. Because I knew it too. We're gonna talk about the Krayt Dragon, and that's gonna be it.
So let's get kind of coming back from that. Sophia, can you tell us a little bit about more of your research, and so that we can kind of get an idea of like, because you're an awesome scientist who's an expert in like really cool like cosmology stuff. Like, so what is it that you study exactly?
So I my focus is dark matter. So it's this stuff that's everywhere, even in your room right now, and it's passing through you and you can't feel it at all. It's 5 times more abundant than everything that we understand. So anything that you can touch and see, but it doesn't interact with light and it doesn't interact with stuff either. So we can't see it, or we can't and we can't feel it, but we can see it by its effect on gravity. So like you could see it when we look when we look at galaxies, the way that stars move tell us that there's more mass than meets the eye, if you will. Gravitational lenses, which are basically they're essentially, I would say, it's like proof of Einstein's theory of general relativity, which tells you that mass bends space-time. So gravitational lenses, you've probably seen images of like huge fields of like galaxies, but then you see these like arced galaxies or like sort of warped looking galaxies. Those are galaxies that are actually way further back in the distance. And because this huge like cluster of galaxies is actually bending space-time, the fabric of space-time, the light that's coming from the galaxies that are behind it is bent around it, which gives you these arcs. So these things tell us the cosmic microwave background, which is basically radiation that's left over from about 400,000 years after the Big Bang, once things cooled off and the universe, once the universe cooled down and photons and matter stopped sort of interacting, we can actually see that, and just the way that you see structures in the universe also tells us about dark matter. I tend to use Darth Vader gifs in a lot of my talks, because the type of dark matter that I study also has sort of like there's a potential for a dark force that we haven't discovered yet. And so I always get the sort of Darth Vader gif thrown up there. But that being said, I mean, like I know this stuff. I also know a lot of things. Like I could talk to you about Tatooine has 2 suns, right? Like
oh yeah,
is that even
We'll get to that iconic shot.
Yeah, and so like other things that I'm of course interested in and know a bit about are things like time travel and the reason, and space travel really, because it's kind of like it's part of what you learn in cosmology and things like that. Not directly, but you learn about the way that sort of time and space behave. It's like a special relativity and general relativity type thing. And so I could definitely talk about that. And yeah.
Well, speaking of, we do actually have a question or a request for a discussion about space travel. Someone in the chat here is asking about a conversation about the orbital mechanics of chasing something while in orbit. So maybe dogfights or any sort of like what we saw in the opening scene of the blockade runner being chased by the Star Destroyer. How they're obviously moving much faster than what it feels like we're seeing. But how would they go about doing that while potentially captured in the orbit of a planet or a moon?
So because they're moving as fast as they are, they're going to be moving much faster than the escape velocity of any planet or moon at all, and so it wouldn't matter. So they wouldn't be in orbit around anything, like they wouldn't be locked in orbit. The thing that, for example, when we shoot rockets up, from Earth, we need to achieve a minimum speed in order to get out of Earth's gravitational potential. And at these speeds, there's like no problem.
There's one thing that I think I've thought about more recently since I've started to learn more about like how like physics works. Since I'm a paleontologist, in Star Wars, like earlier, they're on Tatooine, and then like we cut to the Death Star or the Star Destroyer, and they're kind of like having conversations across the galaxy that are happening at the same time, but they're from what I kind of understand is like time moves differently in different, like depending on where you are in the universe and stuff like that. So there's no way that they could actually be like having a conversation with each other in real time, right?
Precisely. And this is something that people often, we often overlook this, but like you can't have that kind of communication. For example, when Perseverance landed on Mars, we had to wait 7 minutes, 3 minutes, or three, or I think it was 3 minutes to receive a signal back because light travels, it travels at a finite distance, speed. And so, you would not be able to have instantaneous communication like that at all.
Or even like, when they dart across the galaxy using hyperspace, it's like they leave one place and they get to another, and it's like time has passed normally for everyone at the same time, right? Across the galaxy. That doesn't work either, right?
So this is I guess the relativity, like where time is relative. What that really means is that for somebody who's moving at close to the speed of light, time moves slower for them. Or if you're in orbit around something really massive like a black hole, time will move slower for you relative to somebody who's not moving at that speed or not next to something that big. So let's say compared to like somebody on Earth. And so like. That being said, we're comparing when you, they don't. That's a good point. I never they've never really shown the passage of time like changing because they should be a lot younger than like when you go land on Tatooine and you've been traveling this fast while these people are just like chilling there. And so that's a good point. That's something that is definitely not reflected.
I think I noticed in this movie more than any of the other episodes of Star Wars, like it's later on when they're actually on the Millennium Falcon and everything, but they are like, oh, we have to wait to get to where we're going. Like it's not as instantaneous of space travel as it felt like it was in other films, but maybe I'm misremembering that. But well, it's like, we actually have to.
That also might just be a movie thing. They might have just decided to spend more time shots on the ship. There's definitely time skips that happen too. But yeah, that is kind of interesting too. We have really lengthy scenes in this one. Once they leave Tatooine, there's like a big war where he's trained. Well, spoilers. Never mind. Spoilers. Getting ahead of myself.
Reno.
Sorry, spoiling everything. Sorry to those of you who are watching who have never seen Star Wars. I apologize.
Is anyone watching for the first time? I want to know.
Yeah, let us know in the chat if this is your first time watching Star Wars. We'll try to be more careful.
Yeah.
Oh, we're seeing this hologram, and like I always thought the holograms were super cool. Like in the 70s, we weren't even like really close to holograms, and I feel like now we've gotten a lot closer to it with using special effects
in hologram performances of Tupac and I don't know about Michael Jackson, but Frank Zappa. They've done hologram performances, concerts that's mind blowing to me.
Yeah. I'm curious, does that still require like a surface that you need to project on? Because I feel like in a lot of in Star Wars, it just seems like it's projected into air, and whereas like in various things that I've seen, it seems like there's a screen that they're projecting on, or something else, or a pane of glass.
I missed the first part of the question. Sorry.
So it's okay. Well, we can get back to the sand question in a minute about Tatooine. But yeah, this thing about holograms of like, can we project onto just thin air, or do we have to project onto a surface like a fabric screen or a piece of glass, something like that, of how light works?
You need a surface for that. Yeah, you need a surface because it has to reflect off of something. I could see that happening, like say maybe in if you had like a smoke or something as well, like when you see lasers kind of passing through smoke,
Yeah,
you could see
like
that.
water.
Yeah. So there would have to be something in order to be able to reflect off of it. Yeah. That's a really good question, though. That's a really good question. I hadn't even thought of that. That's great. Yeah.
See, we're all helping each other learn today. This is great.
We actually have a couple questions. Well, we were going to talk maybe a little bit about the sand on Tatooine and the idea of whether or not there's sand that would be like our sand on our planet on other planets. But we also have a question about the science of moisture farming. So I wonder if we could talk about both of those things. I just didn't want to let that get away from us before we moved on too fast.
Well, for sand, we have.
It's coarse. It's rough.
I knew you could do it.
It gets everywhere.
For sand, it's like, here on Earth, we apply a lot of the principles of geology to, the greater universe. So, like, there's certain types of minerals that we have, and certain minerals will form based, like, depending on what type of environment you have, like deep within the core of a planet, depending on how much pressure or heat. Lava will cool at different rates and create different types of minerals and rocks. So, that's kind of accepted. That's going to be a little bit of a universal throughout, the universe, I guess. So I think on Tatooine, we're assuming that it's going to be the same, that a lot of the rocks and minerals on Tatooine are very similar to the ones you'd find here on Earth. So looking at that sand, it's probably going to be like very quartz heavy sand, very much like you'll find here. The one thing that I like to talk about in Star Wars, if when they were going through the desert and they were going through those canyons, a lot of those canyons had stratigraphy. Basically, in geology, rocks deposit one on top of each other in like these layers, right? And so that helps us read the rocks or tell time. The rocks on the bottom are older, and as you go up through the layers of rocks, they're younger through time. Those are all made because of like water deposition. They like bring the eroded rocks and like deposit on top of each other. So here on Tatooine, that's really cool because that's showing us that we had water at one point, or some kind of fluvial environment, like floodplains or something. And as those went around and eroded the bedrock, the original rock that was there, and then eroded those, that's probably what created the sand, as we see it now. But also within the Star Wars canon, it was in the original canon, Tatooine used to be a jungle-y planet, I think it was, and then it got glassed from orbit, which means they just shot a bunch of lasers onto the planet's surface and just caused everything to be destroyed and, burnt up, and then that all turned into the sand that we see today. So there's the in-universe explanation, and then there's the more scientific explanation about the sand. But that's kind of what I think they were asking, right? Did I ramble again? I do that a lot.
My sand question, that was a great explanation of all the sand on Tatooine. But yeah, okay. I'm curious about sand on other planets in our universe and like how feasible that is.
So,
like on Mars, it's the same thing.
That's exactly what I was going to point out, right? I was like, we got Mars, like, and Mars actually also has some of the features I think that you were talking about that tell us that water used to exist on it.
Yeah, and like in terms of moisture farming, oof, that's a little bit outside my wheelhouse. I would assume that like, well, because like if they're able to be on the planet to breathe, and if there has to be some moisture in the air, Otherwise,
Right.
they'd probably just desiccate completely.
There is an atmosphere,
Right?
obviously, and there's oxygen.
Okay, so so on Mars right now, as it is, the atmosphere is very thin. It's like 1% of the atmosphere that we have on Earth in terms in density, and so and also in terms like it's mostly like carbon dioxide. So there's one of the missions one of the little experiments that they sent with Perseverance, which just landed on Mars not too long ago, is called MOXIE, which is taking carbon dioxide and converting it into oxygen. So and the reason for this is because, well, oxygen is required for propulsion, and so if we wanted to send astronauts to Mars, we'd need to be able to get them back here, and the only way to do that is with a lot of oxygen, and of course, in order to breathe. So. But stuff that we do know, like for example, there's we got polar ice caps on either pole of Mars, and so there's that type of, I guess, there's dry ice in that sense, but like not sure if that directly answers the question, but yeah, so we don't have oxygen on Mars like as it is, and so. But that's why one of the experiments is trying to do, and it has actually converted.
Yeah, that
dioxide to Mars.
It's awesome that we can make oxygen. I'm curious though that if there's ice there, but it's like carbon dioxide ice, we still would need to get water potentially. We'd need hydrogen, and there's not necessarily hydrogen as part of carbon dioxide or dry ice. So that moisture farming in terms of like getting H2O might not necessarily be possible on Mars currently, but I feel like there is some aspect of it on Earth that like people are they create environments to try and increase the humidity of a space and take out the condensation like that. Like greenhouses kind of do that in a way, right? They increase the amount of humidity and get that taken up by their plants, but not necessarily in a desert.
So maybe that's how the moisture evaporators work that they have on their farm.
So, sorry, really quick. The scene now knowing all of Star Wars, this scene cracks me up because R2-D2 is a little shit in my head.
Yeah,
right?
he knows who that is. I mean,
like he never had his memory wiped, and there's Obi-Wan who also is being I don't know if Obi-Wan's memory or whatever. How does he not remember R2-D2, the droid that was his Padawan's droid who saved his butt multiple times? And then there's R2 like, oh, I'm scared. I don't know who this is.
Maybe
and I'm just like,
he has PTSD. Maybe he just doesn't want to he's blocking it out. I do want to mention that when Ben enters the scene, the sound that he makes is the sound of a crate dragon, apparently.
That's what the crate dragon's supposed to sound like? Or
for a smaller one, maybe.
Okay.
Now that we know now they know how big they can get in The Mandalorian. That's season 2, episode 1 of The Mandalorian. If you haven't seen it, we also have a question. I want to go back to the twin suns thing because we definitely missed that scene, the binary sunset scene, and we have some people who are interested in knowing about the binary sunset scene.
Yeah, it's real. It could be real. There's a whole bunch of binary star systems that people have identified using, I think, the Kepler telescope. And they're trying to figure out whether some of these planets that are orbiting two stars that are orbiting each other, or they're all orbiting each other, there's different arrangements, trying to figure out which ones are habitable. And it's possible that some of them are, which is very exciting. There's a recent article that I think just came out today in Inverse magazine online that one of my friends wrote that you could check out that talks a little bit about this. But yeah, do you have any insight on these binary systems, Sophia?
Yeah, so binary systems are actually, binary star systems are actually the most common. And so having planets around them is almost inevitable. I think they have detected a few. The problem with habitability on these or in these systems rather is that you need to have like a specific type, as you just mentioned right now, that there's specific arrangements, and some of those arrangements make for stable orbits and some of them make for unstable orbits. If you have an unstable orbit, there's no habitability possible because you're going to have you're gonna have like, you know, you might go, you know, too close to the sun at one point, or one of the suns, and that means, you know, you get roasted in on one side, and then the other side you get completely like frozen, and you might just actually be tossed out of the system. So so it really depends, you know, to have a habitable planet that orbits a binary system, you have to have a very specific arrangement. I think you'd need to have, rather than the planet orbiting one star, like rather than the planet orbiting one star, you can actually have that arrangement if the other companion star is very far away. Or you can have a planet that orbits both of the stars together, but it would also have to be like a pretty great distance away from it so that its orbit is stable. So the key is to have a stable orbit.
So how accurate is the depiction of the sunset? Because they both look about the same size. Is if for them to look about the same size, would those two suns be way too close together?
Not necessarily, because it could, you know, it's again, you know, we're looking at a two-dimensional projection, and so because the suns move around each other, you might, like, let's say one of them is actually smaller than the other, but what if one of them is actually closer to us than the other is? Then it would actually appear to be larger than it actually is, and so you can have you can definitely have something like that. Yeah, it's fine. Yeah, there's nothing like out of the ordinary there.
How is it? Sorry, can you explain to me, or for some of us who might not know, not specifically me, how is it exactly that the gravity works that two suns orbit each other and then things orbit the two suns as if it's one thing? Like, how does that work exactly?
So essentially, what with gravity, what you have is a massive object is kind of creating like a bowl in space-time. So if an object gets caught in that bowl, it's going to be in orbit. So if in orbit around this object that's creating this sort of bowl, it's called the potential well, the gravitational potential well. And so if you have these two stars orbiting each other, they can create a well around them that a planet can also fall into and orbit around both of the stars. Does that kind of make a bit of sense? Yeah. So like this is actually something that I wish I could, like, if I had like you know, some to demonstrate it is like, you know, if you had like pantyhose or something and then you threw like an object on it, then you can see how it kind of just bends. It bends the fabric that you're holding. So if you have suns that are closer together, then you can make that bowl kind of like one. If that makes sort of sense, and then that's kind of how you'd have a planet orbiting around both of them.
That is so cool. I love science.
Yeah, me too.
That's just one of my favorite things, though, is like when you learn something and it just makes you smile because you're just like, that is so cool. That's what I love to do myself too, but that's why I just love learning about things, and like movies like Star Wars can help you like ask those questions. Like, how does that work? Is that gonna be possible?
Also, did we even know that like binary star systems were a thing when Star Wars came out in 1977? I feel like it's more like the articles that I've seen about it are more recent than the 70s. So I'm not sure.
That's actually a really good question. I'm not, you know, I really want to know the answer to that right now, but I don't. But I think you're probably right, because, well,
I wonder, powerful enough telescopes to, like, how do we identify these and find these kinds of things?
So usually the way that we find them, the way that we, I guess, detect whether they're, I guess, in orbit around each other is by sort of, I think, like their redshifts and stuff like that. Because if you have redshift, okay, let me explain what that means. So because if you have an object that shoots out light at you, which is, like, say, you know, a star, it, you know, shoots out light. If that star is moving away from you, it's going to cause the light that it shot out towards you to stretch. That's called a redshift. It's kind of like, you know, when you hear like an ambulance pass by you, and as it moves away, that you hear that kind of, right? It's because the sound is kind of stretching, the wavelength is stretching. But when it moves towards you, it gets crunched, so you get that kind of thing, right? It goes like sort of, it gets high pitched, and so if you have something moving towards you, you get that blue shift, so you get that the wavelength of light is scrunched in that way, and so that's one of the ways that you can tell. But I'm really curious to know, like, I think
I just did a quick Google.
Okay.
According to Wikipedia, which is, a good starting source for folks to start down a research journey. Nothing wrong with starting at Wiki. By 1803, observed changes in relative positions in a number of double stars over the course of 25 years and concluded that they must be binary systems.
Yeah.
The first orbit of a binary star, however, was not computed until 1827 when Felix Savary computed the orbit of Chi Ursa Majoris.
Yeah, that makes absolute sense. I don't even know why that was like kind of like a question, but like in my mind. But yeah. Because I mean, if we just look at the planets that have been discovered, the planets are a lot more difficult to detect than stars are. And so, like if you for example, like Uranus and Neptune. Well, Neptune wasn't discovered observationally. Neptune was actually discovered through math, which is a really cool story. But Uranus is very dim, yet they were able to detect it anyway. So something like that, it should have been they should have known about something like about binary stars quite a long time ago. Yeah,
that actually blew my mind because the time scale there was like, sometimes you don't realize like how advanced, how many cool things we discovered like way back when.
Yeah.
Like, compared to now, and when I read that, I was like 18 something. I was like, oh, okay.
And
that's
it makes
amazing.
sense too, because like I don't know, when you, like, at least for me, like in Los Angeles, the night sky sucks. It's like terrible because light pollution just drowns everything out, and all you see is like the Big Dipper, and that's about it, and the moon. But if you move out of the city, you see you can see like the band of the Milky Way and everything. So if you look at like the 1800s, when there wasn't light pollution wasn't really a thing, they would have had great skies to look at, and so they would have mapped that, I think, and figured out that there are these sort of motions, and it's like, oh, okay, these two things must be moving around each other. Yeah.
I want to say we went past the scene where Darth Vader says where Darth Vader chokes Admiral Mahdi and says, "I find your lack of faith disturbing." But I just want to point out a little trivia here. The guy who plays Wilhuff Tarkin, Grand Moff Tarkin, Peter Cushing, he didn't like how his shoes felt. They were very uncomfortable. So every scene with Peter Cushing, since you never see a full body shot of him, he is wearing slippers.
What?
He is wearing slippers. So when you see him in this next scene coming up right here on the Death Star, or actually no, that's never mind. He's not coming up on this one. But every scene, including later when spoilers, when he decides to blow up Alderaan. Sorry for those of you who's first time watching. He's wearing slippers. He's making a grand decision to destroy a planet in his little slippers.
I really hope Kylo Ren and General Hux were also wearing slippers later on, because I feel like they have even more anger. Just imagining them saying that while wearing slippers is great.
I mean, I feel relatable to that since we've been digital for the last year. A lot of my Zoom meetings, I'm like presentable from here up, and I'm wearing like slippers or socks right here.
Or like PJ pants, like I'm wearing right now, which you guys can't see. Yeah.
Wow. Am I the only one who went all out and borrowed a costume that was got the pants and everything?
Oh no! This is a jumpsuit. I have the pants. Don't worry.
I believe.
No, I'm the only one here because I'm just Grogu's keeper today, so I can wear what I like.
A comfy mom to take care of it.
Yeah.
I would like to see the child.
Oh, here we are at like the important decision of our hero.
Yeah. But that would lead them back
home. So we did just see something really important. I don't know. I feel like someone is gonna eventually ask a question about the Death Star.
Oh
Yeah.
yeah.
I really hope that, because if there's anybody that doesn't know this, we do have a Death Star in our solar system, and that's a moon that's orbiting Saturn. It's called Mimas. If you want, you could Google it just to see what it looks like, but it literally looks just like the Death Star, but it's an actual moon of Saturn.
Did it like get the indent from like an asteroid or something? Like does it have that?
Yeah. So the giant crater, it's
Yeah.
probably yeah.
Okay.
Most likely it's like from some sort of like giant collision.
Okay, ignore these special edition scenes. Just ignore those. Just ignore
Yes,
that.
all of the CGI.
All this CG.
I'm like,
Ignore
what did
that.
this look like before? Am I ever going to be able to find out?
Yeah, I have a question about the Death Star. Since I don't know if it's necessarily big enough to be classified as a moon. Oh my God, that's CG. Okay, sorry about that. I don't know if it's actually big enough to be classified as a moon, since he says that's no moon, it's a space station, but it's pretty big. Is it big enough to have things small, like much smaller objects orbit around it?
Let me,
You think? We
so
had to pull up some specs on that.
let me. So the Death Star is like 100 miles across.
Oh, okay.
Let me hang on.
Have astronomers made up like a cutoff point of like that's a moon versus that's not a moon at like a certain distance.
Oh my
Well, I
God.
mean, they
these
decided what's a
CG
planet and what's not a planet, so I'm
That's
sure they
true.
can do the same.
putting in these CG Rontos in the background. I hate it. I'm sorry.
Reno.
Unnecessary. These Rontos.
Okay, yeah, they're
So-
unnecessary, but they're also really cool animals.
So
Creatures.
actually, one of the oh god, yeah, please go ahead, like yeah.
No, go ahead. Go ahead.
Yeah, so like one of the moons in our solar system, which orbits Neptune, is like really small. It's more like 500 kilometers across, which is like less than 5 times larger than the Death Star. But I don't know. Wait, have asteroids had things orbiting around them? I'm really not sure, but you technically could. You technically could. The whole question is, can you even create anything like that?
That's
Yeah.
the question right there.
To
like
compare, yeah.
like the amount of resources it would take to just build that. Like, I mean, sure, they have a galaxy of resources available to them, but also like, I mean, this takes place what? How many years is it after episode 3? 16, right?
19.
19 years.
Luke and Leia are 19.
19, right? So that's 19 years for them to build something the size of a moon. That's a ton of metal work and all that. Sure, the Geonosians probably built really good, easy plans for them to follow, but like, that's just ridiculous. And the amount of time it would take to build that much. I mean, like, think of how long it takes for a moon or a planet to form in our own solar system.
Yeah, you know.
Go ahead. Oh,
Yeah, right, like the amount of metals that you would need, like if we were to go about doing that like in our solar system, I don't think that we would be able to. But like also, just something to compare. One of the biggest things that are human made in space, is the International Space Station, which is really big. It's the size of it's the length of a football field. Okay. But that's not 100 miles, okay? I think that's what a football field is.
120 yards.
120 yards, which
How good someone knows sports.
What would that be like about 100 meters?
Yeah, because it fits inside of a track. Yeah.
Okay. Yeah. So that's really tiny compared to 100 miles, and this thing took 10 years to make. That took 10 years to make.
Yeah.
So imagine a Death Star then.
Yeah, and all of the like buildings and like I'm thinking like how did they even have people build this in space? Was it built on a planet and then moved? Because like doing any kind of mechanical repairs on the International Space Station is always a very big ordeal.
It is, yeah. And so like I mean putting stuff together like that would be nearly impossible. Like one way I guess that we do things in space when we want to like send out an object that's gonna kind of like get really really big, which I think the James Webb Space Telescope is gonna do. That is that we have like a sort of origami type thing where we send out an object that kind of unfolds. in space. So that's one way that we can get something larger out without sending it in its like sort of, you know, original form, is by sending it compact and then having like it unfold in that way. But, you know, as far as getting all these pieces together,
in Star Wars, what they do, they have like shipyards, like that they build all those things in space. So I would assume that it was like within the narrative that it was built like in space, and then it was able to move and stuff like that.
Like quad drive yards and everything.
Yeah.
Yeah, like I mean, if you were to build that on Earth, how would you even shoot it up? Like, that thing's got to be like mass. I don't know what its mass is actually. You know, I want to
calculate that out.
Okay, yeah. I want to say we have a couple engaging questions, and I just want to address them so we don't forget them, so we can come back to them. Before we do, I just want to say, now that we're in the cantina scene and we've crossed the gruesome part where Ben cuts off Ponda Baba's arm, this is one I have a gripe about this. For all the things they decided to change in the special edition, they didn't go back and make his arm look like the wound had been cauterized by the lightsaber, because that was a big deal when spoilers, when Luke Skywalker gets his hand cut off by his dad. Also spoilers.
Reno.
The wound is cauterized so that they could get the PG rating so they wouldn't show any blood, right? And that became canon. Lightsabers cauterize wounds. But for all the stuff they added to the movie in the special edition, why didn't they go back and make that shot look like the dude's arm was cauterized as opposed to bleeding? So it's just a gripe of
That's a really good point.
We're also coming up on some weird BS.
Maybe it was cauterized, and then it fell on the floor, and the pressure when it fell on the floor caused the blood to leak out, because it's not bleeding. It's just a little blood splatter.
Someone spilled their drink or something.
Yeah, let's go with that.
We're also coming up on the Greedo versus Han shot first scene. I just want to say that the special edition changed who shot first to a less favorable way. But there have been many different changes over time in the different DVD releases and Blu-ray and this final Disney Plus release. So what we're going to see is like the third or fourth iteration of how they've made it change. So now it kind of looks like they're both shooting each other at the same time, and Han Solo's head still kind of juts to the side unnaturally. Just a heads up with that. Here's Greedo. But we have a couple questions here. One of them I think we should get to later, because I wanted to talk about gas giants and Yavin versus Yavin 4, and I think that's a good way of transitioning to talk about life on other planets. We have an important question about that. But before we get to that, there was a question from my mom about how the sand speeder stays afloat. And I will say, production wise, it's made to look like it's floating because it's actually a car and there are wheels, and they use mirrors to make it look like there are no wheels. But can we talk a little bit about having vehicles that we have in real life that float along the ground?
Yeah, I feel like there are some hovercrafts. I don't know that I've seen any that work on sand, so I would always...
There goes Greedo.
Yeah,
bye
sorry.
Greedo.
Like if it was actual hovercraft on sand, I would imagine there would be a lot more sand moving underneath. Like if you see a helicopter above sand, like all the sand is moving.
That's a good point. Mm-hmm.
So that is one aspect that could have been made more realistic potentially. But
I mean, I feel like I've seen like those hovercrafts like go over like beaches. Yeah. Right? Because I think it's just sitting on like, it's just the tiniest cushion of air that allows it to just glide over the sand, because like it's just sitting on that little cushion of air.
But
and the force it's exerting with its giant fan in the back is greater than the force of gravity, so that would just allow it to push forward. In my very limited understanding of physics, I don't know why I'm trying to talk. I have an expert right here with me.
It's also not powered by air, though, in Star Wars. I'm assuming it's not.
True.
They're not using air. They're using some sort of magnetic or gravitic device or something. I don't know.
Yeah. So I mean, this is kind of like similar to, you know, in Back to the Future, where they had the hoverboards and stuff like that. I guess it's kind of similar to that. I don't know if you all saw the meme when it was 2015. People were like, "Where's my hoverboard?"
Yep.
You know.
Yep.
I asked the same question.
Yeah, we don't have something like that yet. But I guess one way we could go about doing something like that would be maybe using the magnetic field, because, or using like magnets and stuff like that. That's one way that you could maybe create some sort of I guess like a hovercraft type thing, because the magnetic force is way stronger than the gravitational force. So that being said, on sand, not so much.
What if you put magnets, like you put like a magnetic highway underneath the sand, and then you had like a maglev train that was just on top of it? Would that displace the sand if the sand was on, or would having sand between the two magnets make it weaker of a like propulsion?
I mean, if you have strong enough magnets, and you're not putting like too much sand on top of it, you can, I think you could do that. Yeah, like that's one way that I would, like, if I had to create something, that's what I would use, is the magnetic force or the magnetic field, and or the electromagnetic field, really, because if you can use the electric force to produce magnetic fields as well. But yeah, like it's depending on, if you don't have too much sand in between it, so you don't have too much of a layer that's blocking the two magnets from each other, then you can do that. Yeah.
That's what we need to get to Vegas faster.
It's a great idea. They're building something.
Are they?
I've heard. I know it's been voted on. I don't know.
Okay, fine.
Some sort of hyperloop thing.
I gotta stop before we go too Californian and start talking about freeways. This is what happens when you get Californians in a room, right?
Just so you know, that scene was, to those unaware, that scene was added back in the special edition with Jabba the Hutt. He is added back in post in CG because the original version of Jabba the Hutt with the puppet did not look good enough, so they cut the scene. That was supposed to be the first appearance of Boba Fett. Instead, the first appearance of Boba Fett was in the 1978 Star Wars Christmas special. He appeared in an animated short in the middle of the film. That was the first appearance of Boba Fett. The Star Wars Christmas special is not canon. It is very funny, but not because it's good. It is very ironically enjoyable. Go check it out if you want to see some good old-fashioned Star Wars fun and holograms of Jefferson Starship playing music and weird animations and Chewbacca's son Lumpy.
Lumpawaru.
Lumpa, I think is his name.
Was it? Oh, anyway.
Something like that. And his wife.
Well, on that scene really quick, that is probably my least favorite of the added scenes in like the special editions.
Well, it's the only scene that's actually added. It's the only added scene.
Anything added to this movie. That's probably my least favorite thing. For one reason, when Han Solo steps over Jabba,
he looks so unnatural.
It's so fake. It's just like the one thing that I just can never let go of. And
also, Jabba's so small, like comparatively to how he shows up in Return of the Jedi. He's so small. Did he gain all that weight in like 3 years?
That's bulking season. He's cut here. He's cutting here.
Okay, all right. Hutts don't generally. I guess I need to read up more on my Hutts. I know he's the only Hutt that lives on Tatooine, and they all thought he was crazy for doing it back on Nal Hutta.
Oh, I have a question, Sophia, for you.
Mm-hmm.
This is one thing that I've always wondered about for Star Wars. In Star Wars, we always see planets, or we always see starships taking off in the same orientation from planets, right? They're always doing that. Like, they always look like they're taking off from the equator, and they're always in the same orientation. But they're globes, right? So like, if you take off from like the South Pole, it really doesn't matter what orientation you take off from in space. You could all kind of be like every which way, right?
So okay. Okay, so wait, in space there is in space there's no direction, like there's no up, down, and whatever, left, right. It's just but I guess I guess maybe I'm not quite understanding the question. Can you ask it again?
It's just kind of like, so like whenever ships leave from the planet, right? They're always leaving from the same direction, and they're always right side up. But I guess in reality, how it could work in the real world is you could take off wherever you want, and they don't always have to like just follow that one. They don't always look like they're coming from the same direction. I mean, unless they're following hyperspace lanes. Okay, maybe I answered my own question. Never mind.
But that brings a whole other question, and we got to talk about hyperspace now. We definitely got to talk about hyperspace.
Yeah. So
Lightspeed.
But okay. So let's. So hyperspace is what allows us in Star Wars when to move faster than light and to get to places in bizarre times that you would not be able to reach. That light can't even reach that fast. So the thing that's cool, I think, about the way that Star Wars did theirs is like I know I think in Star Trek they use faster than light travel in a sense that they kind of takes the space in front of it and scrunches it down so that it's instead of it being like this long, it's this long, and so that's how they do it. Whereas here, faster than light travel it's not possible. It's like it breaks a law in physics called causality, where like I can get a message to you, and you'll get that message before I've even given it. And the way to in order for me to explain that, it's like you actually plot this out. It's just because space and time they're literally like a fabric. They're weaved together. It's you can't just move around in whatever which way you want, in whatever at whatever speed you want. You can't do that because essentially like it's really true when you hear about things like when people say that I could if I was traveling faster than light, then I can get a message to you before I've even given it. So you'd get a message from me before I've even actually given it to you, which is like it's really weird to see. But when you see when you see like the graphics and the graphs and all that, you can actually see it, which is like it's mind blowing. But so you can't do that because it's kind of like the grandfather paradox is like if I can just because that's time travel. So that's the whole thing is if you do faster than light travel, you're essentially doing time travel as well. And so the problem with that is that I can actually I can go and say kill my grandfather, and then that means like what would happen to me, right? if I were to do that. And so what I like about the way that what Star Wars did is that they use hyperspace, which is they use this kind of like an extra hyper dimension to kind of get past using faster than light travel. Is that possible? We've never found any hyper dimension, and so as far as we know, no. But one of the ways that we could do, which one it's my favorite like possibility, is a wormhole, or what you've probably heard in if you watch like the Avengers and or Thor, the Einstein-Rosen bridge. It's a wormhole. So essentially, what that is like let me get you a paper. So like it's like a shortcut through space-time. Yeah. So if I have like this sheet, a wormhole would basically kind of like fold. It's like a tunnel through space-time. So that instead of me needing to travel from here all the way to here, instead of me traveling all that distance, the wormhole would allow me to just travel this little distance. So it gets me from point A to point B in a much faster
I've heard of it described as like if you poke a hole through a paper, yeah, and you were to say like, okay, so if an ant wanted to crawl from one side of the paper to the other, it would normally have to crawl across the paper and then to the other side to get to the reflected point. But if you had the hole in the paper, it could go a little bit ways and then just go through the hole and come out the other side.
Exactly, right. The only reason why I didn't poke a hole through this is because I actually need this sheet of paper, because I was literally going to go do that. But yeah, because then you have it's a literal, like it's a tunnel that gets you from this point to this point in just that really short amount of time, rather than traveling that entire distance. You just travel through the little tunnel that connects these 2 points. And so that's, I think, the most exciting and somehow still the most realistic, and I say that very carefully, realistic kind of way to do it, and I say that carefully because we've never discovered any wormholes at all. And also there's an issue with using wormholes is that they're unstable, and so we'd need like a type of matter that doesn't exist right now in order to be able to hold them open. Otherwise, they would just collapse on us and we would just die. So that's the most, I would say, the most. It's still the most realistic way
Plausible.
to do like space travel. But hyperdrive, I like it because they kind of get around the faster than light thing by introducing this extra hyperdimension.
I love that. That's so cool.
Is that like the brain universe? I was BRANE. I was looking into it, and I'm seeing stuff about the brain universe that has different physical laws than the universe that we inhabit. So basically, they're going into another dimension when they're in hyperspace. Hyperspace itself is another dimension.
Yeah. So the brain universe is one of the things that comes out in string theory. It's one of the ways I think that they explain multiverse. So if you have if you have brain universes, then they can kind of like they could be like sort of they're like these kind of like sheets or brains, if you will, like BRANE, as you said. But I think that in this case, it's kind of like a hyper dimension. It's like, it's not even really an extra dimension, because it is an extra dimension, but it's not like, it's a hyper dimension, meaning that it's not really a spatial dimension, which makes that's where it kind of like gets weird, because you can have extra spatial dimensions, but you have something else. I don't know. Maybe higher dimensions would allow you to get to this hyper dimension, and the problem is being able to access it, because you need a lot of energy.
Are there like scientists out there whose specialty it is to like figure out if we can do that kind of stuff and like get faster than light travel?
Yeah, like there's have you ever heard of the Alcubierre drive?
I don't think so.
Okay, well that's actually it's a one physicist who worked out like a way to actually create a drive that you can use in order to like be able to travel sort of quote unquote faster than light, or rather get around that, if you will. And yes, it's something that physicists do, like really hard theory type physicists, like wormholes. They came from that too. Like it's worked on. It's been worked on. And so, goodness, I forgot the physicists' names, but there was. This is gonna bother me, but because there were these two physicists that came, like when the wormhole came out as like a possibility to sort of travel through space-time, they came back and said, well, you can't do that because wormholes are unstable. And so I bet you there are people watching right now screaming the physicists' names, because it's not it's a relatively known thing. So hang on, let me try to figure this out.
I think it's important to normalize that scientists don't always know everything, and that we look up things all of the time.
All the time.
Absolutely.
So
I there's like times that like we're doing tours for second graders at the museum, and they know so much more about dinosaurs than I will ever know.
Yeah. I mean, okay, so aside, well, Einstein-Rosen bridge is, so those are two scientists, right? Einstein and Rosen, who came up with them. But I'm looking for the scientists that said, here we go. John Wheeler and Robert Fuller. They are the ones who found that it's unstable, and so you can't just use a wormhole just like that. But who's the physicist that came back and said you can do it as long as we get this weird exotic type matter? Kip Thorne. Kip Thorne. Kip Thorne is the mastermind behind all the stuff that you see in Interstellar, and so he's the one that came and said, yeah, we can actually use wormholes if we get this weird exotic matter that doesn't exist to hold them open.
I'm writing those names down because I'm going to be reading about this late tonight. So
yeah, Einstein, Rosen, Wheeler, Fuller, and obviously Kip Thorne. He's really cool, and he's also really cool like to meet in person. I've met him, and he's really awesome.
For like a lot of this stuff, because you said we've not observed or any of these things, like for those who may not be familiar with physics, me, how do you come to these conclusions? Like, what do you do exactly?
So for, I guess, for people, for theorists who do like fundamental theory, they work like kind of like they create things from the ground up. This stuff comes out in the equations. When you start playing around with the equations, you find like weird things, like so you might go about, like, say, a current theory that you have, and you kind of start working it out, and you might have like some idea to throw in some sort of extra, I don't know, field or something, and then you kind of see where it takes you. And then when it takes you somewhere that doesn't give you extra things that tell you that there's something wrong with what you've come up with, then you're like, oh, whoa, okay, I've just come up with a wormhole. Like, these are actual equations. There are actual equations that describe wormholes, literally, in general relativity. Like, I have my textbook right here. I could show you. They're actually equations that describe these things. So it's incredible that, yeah, this stuff is, it's real. It's like there's physics behind it.
That is so.
Yeah.
My mind is absolutely blown right now. Just because, like, I'm a paleontologist. I work with like rocks, bones, something that's in front of me. I do, we do with some foreign, like, abstract concepts like evolution, but like, peering into, I'm gonna sound so stupid, but peering into the fabric of the universe and like using math to just like calculate things that we can't see is so cool.
That's totally not stupid. That's awesome. Like, yeah, I would say I totally agree with you. Yes, it is. It's freaking cool. And that's why we do this, right? Because it's just that awesome. It's really cool. Yeah.
Let's see. Where are we in Star Wars? I kind of lost track because I was so.
They're on the Death Star. They've been
cool.
brought in by the tractor beam. The music sounds an awful lot like Mars from Gustav Holst, The Planet Symphony, or it did, not now, but it did when they were being pulled in. I
had a question.
Yeah.
So like when they come out of hyperspace and they're coming into where Alderaan was just blown up, right? Because they were looking for Alderaan. Like, do we think that the way that they depicted the aftermath of Alderaan being blown up as like somewhat realistic, with like all of this matter flying everywhere? Like, how does that affect the gravity?
There should be more. There should be more stuff. Wouldn't they like run right into it?
Do we know?
I'm gonna have to see it play out for me again before I say something that's incorrect. I want to make sure like that I'm not saying something wrong to you. So
it just looks like a bunch of little rocks. It doesn't look like the chunks that you would expect to see.
Yeah. Like how it was destroyed and how like conservation of matter works with these like laser blasts and how powerful it was, and whether that turns into gas versus solid matter or something.
And I think that would also create, eventually, over a long amount of time, would create another asteroid field if it was orbiting something. Because I know this might not be canon anymore. It's definitely from the Legends canon, not the current canon, but which I prefer the Legends canon.
Yes.
I think there is like a mass graveyard of Alderaan chunks that people visit sometimes to pay their respects, because there are only a few Alderaanians who survive, since I mean, obviously people travel all over the world, but they, after a while some people die, and eventually, if you think about it, if you're in the internal history, in-universe history of Star Wars, at a certain point there will be no people who are ever from Alderaan because their planet was destroyed.
True.
Mm.
But anyway,
the asteroid field thing that you mentioned was actually really, really interesting, because our asteroid belt is kind of like a failed planet as well.
Right.
Yeah.
Did it not, like, that all the asteroids just didn't have enough like gravitational pull to like form together? Is that why it?
That and also you have Jupiter there, so Jupiter kind of keeps it as it is. Jupiter has asteroids kind of like in specific orbits because of its immense gravity, because it's so huge. It's like the most massive planet in the solar system. It holds sort of their orbits in specific places, not the entire asteroid belt, but specific ones. And so, but yeah, these are ones that they just didn't. Somehow they just kind of couldn't come together and coalesce to form a planet. Yeah.
Very cool.
So that's what we're looking at. It's like a failed planet.
Not necessarily a destroyed planet, just a failed one.
Yeah.
Destroyed by a man wearing slippers. Man who was very comfy. Very
He was
comfortable
comfy while
when
he
made
was
that
like
decision.
murdering, snuffing out hundreds of lives. It's fine.
Oh,
fine.
hundreds.
Oh, millions. Sorry.
I mean, and
I'm
that's
distracted.
that's if we're just talking
distracted.
about. That's if we're just talking about like intelligent life forms. I mean, the entire ecosystem, the whole thing's gone.
I was sad. Okay, so this is one of the things that I was sad about when they showed Alderaan like very briefly in Rogue One, right?
Mm-hmm.
And at the end of Episode 3, I was hoping we would see Thrantas, but they never showed them. For those of you who love like the original canon, Thrantas were like these giant flying manta ray-like creatures that were native to Alderaan, and they would use them for transportation. Again, check out Tara Whitlatch's Ecology of Star Wars. But I was hoping we would see them, but we never got a chance to see them, and that's one of my things that I've always wished I could see in Star Wars.
I'm of the opinion, after watching a couple of videos on how the prequels could have been improved, I'm of the opinion that rather than going to Naboo, all the things on Naboo should have been Alderaan. Just from a storytelling perspective, because it makes it so much more impactful when we see the planet blow up. Mm-hmm. That like, we know people from this planet. We know the senator of, Padme Amidala. She was the queen and then the senator from Alderaan. Her friend Bail Organa, who should have had more screen time, was from Alderaan. All these beautiful shots shot in Italy. They wouldn't even have to like change the way they shot it. They could have just decided that was Alderaan.
But we would have had Jar Jar Binks.
They still could have had Jar Jar Binks. Think about it. Easily, guns could be a thing. They shouldn't have. But guns could have easily all they had to do was call it Alderaan.
Okay, we're gonna start a whole separate conversation for this, Reno, because I know where this will go. So we'll put that one on pause for now.
All right. If anyone's interested, just check out Belated Media's videos on what if Episode 1 was good, what if Episode 2 were good. He has one for each of the prequels. Check those out. Very good storytelling.
I love Episode 1, 2, and 3.
Though,
yeah.
Just one thing I will say though, Sarah, is that like, in order to destroy a planet like that, like you'd need incredible amounts of energy. I can't really foresee what you would need in order to be able to do in the first place.
Yeah, I actually looked something up recently, or it came up in my timeline that there's a lab near me in Northern California that a couple years ago did something that was close to the Death Star of combining a whole bunch of lasers, and so it's the National Ignition Facility, I think, NIF, at the Lawrence Livermore National Lab. They combined 8 lasers into one beam using some plasma, because without the plasma, the lasers they would just go right through each other. But they combined 8, and it had almost quadruple the power of one laser. And they have 192 lasers. And so I haven't seen any news about combining all 192, but potentially.
What is the laboratory called?
Lawrence Livermore.
Oh, nah. Lawrence Livermore. Okay, gotcha.
Yeah, not Lawrence.
That's like the start. That's like the intro of a Marvel movie where some mad scientist breaks in, like, I will now steal all these lasers and I will hold this country hostage.
Yeah.
Also, really quick, my favorite line from the movie just passed, where Han Solo was talking to them and
he's
like,
fine.
How are you?
How are you? I say that foreign conversation anyway. Drew, we got company. Kid, we got company. Luke. By the way, we also did have a question earlier about whether or not the Death Star would collapse under the weight of its own gravity. Let me go back and see if I can find that question.
So for that, I'm still not seeing what its mass is, but in order for that to it wouldn't.
Is it?
I put some interesting links. If anyone wants to check this out, I put some interesting links on the internal workings of the Death Star and the science of the Death Star. So, I'll post it again. But yeah.
So let's just give you an example. So for Miranda, which was the moon that's around Neptune, that's like, I think, one of the smallest moons in our solar system. No, there are smaller ones at that. We have like mini moons. Hang on, what about mini moons? Yeah, Saturn has mini moons. Where am I even going? It would be like a mini moon for sure. That's what it would be like. But let's so hang on. Let me think. Let me just type out see what the mass is.
Calculations live.
This is live science, folks. While we're at it, I had never really noticed, but Han Solo was just like shooting wildly into the air. He wasn't even trying at that point.
Oh, do we miss the spot where
together.
Do we miss the spot where the stormtrooper hits his head on the
I think we did miss that.
Yeah, and then like they edited out the sound, and then in later versions they like edit it back in or whatever.
That's hilarious, honestly. The first time I saw that scene, I think I played it back like 4 or 5 times because I was just cracking up seeing the stormtrooper just. Oh wait, here it is. Is this it?
Oh, it's here. Yes,
coming out of the elevator.
Maybe when they're like.
No, okay. Well, anyway.
Fuck them all down. Yeah.
Okay, so here's a pretty smallish moon. It's similar, I guess, to. I would say this is like double the size of the Death Star. This is more like it's oblong. It's not even spherical. But let's just say about 250 kilometers if I was to take an average. Okay. Across. So I mean it literally has the mean diameter in front of me. So it's like 271. Yeah. So I was that far off. So it's about twice. So this thing has a mass of 10 to the 19 kilograms. That's a 1 followed by 19 zeros. Kilograms. Okay, and it doesn't collapse under itself, and so I can't imagine that the Death Star would be 10 to the 19 kilograms. You know, so that's where for something to like I guess collapse on itself under gravity. Wait, hang on a second. Let me think about this.
I'm curious, like how much air is allowed, or
right,
because the air still has mass.
Because we have hollow space, right? Mm-hmm. And that's a problem. That's why I stopped. I'm like, hang on a second. Wait. Okay, now I'm thinking twice. I think I would have to know how thick it is. I couldn't find what the mass of the Death Star is.
I can't imagine that should be too. That information has to be out there. There's so many books. Again,
there's gotta be some nerd who's got that.
This information there, right? Exists, like, and it's like canon information. Someone did have to figure it out. Like it was decided.
So I guess what here's what I'll say. If it wasn't to collapse under its own gravity, it would definitely not be able to have things in orbit around. That I'll say for sure.
Makes sense.
Yeah, because it's hollow.
I want to point out we're at the scene with the Dianoga.
I hate this thing. It's so gross.
It looks pretty grody. And in the older canon, I think it was said that the Dianoga just like snuck aboard some trash stuff and ended up in here. But in the new canon, I guess it was decided that the Dianoga was put in there on purpose so it could just eat stuff, like anything that ends up in the trash. Like, instead, it was put there on purpose. And I thought this is maybe the only other time until we get maybe to like life on other planets where we can actually talk about some bio. If anyone's interested in talking about animals or organisms, I should say, that eat trash.
Well, wasn't there a question earlier about the probability of life?
Yes. But we're talking about the Dianoga right now. We'll get to that question. I have stored that question. I will bring it up when we talk about the life on Yavin 4 as a moon around a gas giant.
I'm curious, what the atmosphere, like all of these different organisms that have the same breathing requirements potentially on all of these different planets and can all coexist as they travel between different planets.
I mean, that's one of the things I think that you just have to let go of in Star Wars.
Yeah.
Like, you know, it's just something you have to let go of and think about and like not think too hard on, because if they did that, that'd be a lot more things to think about in terms of narrative and pieces.
It wouldn't look good.
Yeah, I mean, they do it sometimes, cool. Right? Like, look at Plo Koon in Star Wars Episode 1 and the prequels, right? Plo Koon is a Keldor, and he's got the pressure masks and the thing for his eyes. So every now and then they create, like, they have these ideas of creatures that need like external adaptations to survive in different worlds. But overall, like a lot of these creatures, they're just super adapted to being able to go wherever they need to be. I mean, they even have creatures that exist in space.
Here's
there
the
it is,
right?
right?
With their heads ahead. Right. Sorry.
Sorry.
It's preceded by the line, 3PO, where can he be? Top-notch acting. Where can he be? Sorry, continue, please.
Anyway. But yeah, like there's creatures that live in space in Star Wars, right? Like they're adapted to living in the vacuum of space.
We're gonna get to this. I was gonna say this for later, but the space slug and the Minox found inside the space slug we're talking about the next episode, but they are silicon-based life forms. Silicon on the periodic table is one row down from carbon. So the idea that there could be silicon-based life forms is a popular one because of its similar structure to carbon, speaking chemically. That's my extent of knowledge that I'm going to talk about chemistry because I was never a fan of chemistry, but I do like it when people who are much more qualified about chemistry talk about it to me.
I like chemistry, but I do not know enough about silicon. I just know that there are lots of labs that are trying to build organs on chips, and they're like a brain chip or a liver on a chip. And I don't know if those are silicon-based chips, but I think it's possible that they would be, and not just like a carbon-based.
Well, I wonder if we could harvest some space slugs in Minox for silicon rather than mine our own planet.
Yeah.
Well, like in the canon of Star Wars, like a lot of creatures are seeded creatures too, like from precursor races. So they've been genetically modified and adapted, and a lot of the humanoid species in the galaxy of Star Wars all come from a common ancestor, because evolution in the Star Wars galaxy takes place on a galactic scale because of the ability for things to travel between planets because of hyperspace and stuff like that. So
as soon as the hyperspace became a thing, because obviously like it was on a planetary scale.
Well, like the Purgle are able to use hyperspace naturally. For those of you who watched Star Wars Rebels.
Yeah, which was pretty insane, but
we're going too nerdy now. We're going too far into the nerdom, so we'll come back.
Cosplay for Science Theater.
Yeah. We'll come back to this one.
All right, we don't have
back
to talk
on the
about
science
trash
part of it, so Sophia. Like, do you know anything about like what scientists say is the probability of other life existing in the universe right now?
So there's actually an equation for that. It's called the Drake equation, and there are people who work on that like a lot, but the probability that there is life on another planet is, I think it's kind of debatable. But for the most part, it seems to be very low. But I mean, if you were to ask me, it's like space is so big, the universe is huge, and in our galaxy alone, we have like billions of planets, and so I mean, why would there only be life here? Let's say like any form of life, even plant life or whatever, anything. And one of the things actually that we're looking into, and we will be looking to figure out is if perhaps there's like life on under the crust of Europa. Europa's a moon of Jupiter. Yeah, and it's basically a water ocean underneath a thick crust of ice, and so that's one of the places that we're going to be looking to try to figure out if maybe there's possibly life under there. We can't get into the crust yet because it's incredibly thick, but if we were to just find, I think, life somewhere there or whatever, that would just change everything. And so I think the most, I guess, the best or the most accurate answer is that we don't really know until we're able to fully explore the planets and moons in our own solar system and see whether there's life there at all or not.
And I mean, to be fair, we haven't even discovered every form of life on planet Earth. We're still discovering new forms all the time on our own planet.
Yes, and there's actually something that's really interesting. I don't know where this is going to go, but they found there's some, I forgot exactly which chemical it is, but it's in the atmosphere of Venus. So if you've heard like something about like the clouds of Venus possibly having life in it, this is something that they're also looking at, because there's a specific chemical that I think is like, it can't be created by by any process unless other than like some form of life that is based on sulfur. And so if that pans out, then that's also a whole different like story. That would change everything for us too. Look, I mean, finding life on another planet, period, would change everything. So once we get to explore that, I think we'll have a better idea for the answer to that question.
I want to.
Yeah, me too.
I hope I'm alive to see it.
Incoming shot added from special edition to show a bunch more stormtroopers. Sorry.
You're keeping the canon.
I gotta keep that. I just want to point that out because that actually I like that shot. That's one of the few things that are added in the special edition. Where I'm like, yeah, I like that.
Really quick,
yeah.
Like segue. When they were designing the Death Star, or I guess this goes for a lot of science fiction, there is no safety regulations in space apparently because hey, let's just have a door that opens to a giant pit for some reason.
Right.
Let's not put handrails anywhere.
The bridge isn't open. Yeah, it's like the bridge should always be enabled if the doors are open.
It doesn't look like there's a lot of stairs, which I think I'm always curious how they film R2-D2 moving around. I've noticed from watching this that there are some cuts where it's like, okay, R2-D2 is trying to go downstairs, but we don't think he can, at least in this early version. So they cut away, and then he shows up like later on.
Yeah.
Yes. The robots that go downstairs are in development. I think they exist now. It's not just like, oh, let me have like fire and like a jetpack to help me get downstairs or upstairs. But
speaking of sorry, Sarah.
Go ahead.
There was a lag. I thought you were done. I'm so sorry.
I am. Go ahead.
Okay. Sophia, speaking of droids, does your field use AI a lot or like machine learning?
Yeah, my field is actually going into using machine learning now because we do a lot of simulation stuff, and in particular, I do simulation work. I don't create simulations, but I use simulations in my work. And so yes, we are definitely moving in that direction. It's very, very, very coding related. And why?
Just wondering, like.
Oh, you were just wondering? Okay, I thought that was like kind of setting the stage for a question. That's why I was like, oh, why?
Oh, no, that was my question. It was like, if
think
you're
about
using it, because it's like,
because I mean, he's basically a human. His AI is so which makes you wonder why he needs to be like that. Because we have translation apps now. We have things that can detect what you're saying and translate it for you. So I just think about in this universe when they have so much stuff, it's like, why did they need to have a droid that was basically like another human that has its own personality and has enough personality to act afraid of things and be kind of annoying?
I think we're getting into the whole anthropology side. Go ahead, Sarah.
That's true.
Yeah, I think that there are some studies of like, especially with kids and like interacting with robots, and we've been studying like, okay, if we make it humanoid enough, is like, does that have benefits, or does it go into this uncanny valley where it makes it really uncomfortable? But yeah, kids are like more likely to learn from something that seems more human, seems like it might have a personality and something that they can recognize rather than, I mean, I don't know if they've directly tested like a humanoid versus like an animal kind of avatar robot, so either a virtual thing or a physical robot that they're interacting with, but it's definitely something that affects their engagement of how much can I relate to this thing that I am interacting with.
Yeah.
All right,
we're
at the first lightsaber battle, so we gotta talk about lightsabers.
Oh yeah, especially the news from today, of all days.
Wait, what news?
What news?
They showed the lightsabers that Disney is making.
They did?
Yep, it's all over their social media platforms. Rey, like, it extends with the light, and it's a specific, like, contained beam that extends, and it's not just like one beam the whole time. Yes. It's becoming real.
Okay.
There's a patent for it. I looked into it. We can talk about it.
I need to say this. Please go on Google and just Google lightsaber. Just do that, and then tell me what you see.
Is it all of the Disney news? It might be biased by my Google searches.
I did a lot of looking into lightsabers today, and I was surprised to find out about some of the possibilities and kind of impossibilities about it. But what I learned is that it's definitely not lasers, because lasers don't bend, so they can't arc. So the idea, like a lightsaber is basically, it has a power source and an emitter, and it uses the crystal within it to focus. Oh, goodbye, Ben Kenobi. To focus to focus the energy, and probably more collimating materials to keep it in line, and then it has a containment field to keep it as a blade. But lasers do not arc. So the idea was that most people would think that it would have to be just like the blasters, and how they use the ionized gas to create plasma bolts, and the collimating materials to put it through. That the lightsaber itself would be plasma, which is of course, one of the states of matter, like lightning.
Yeah, exactly. That's how you'd be able to create like a real life lightsaber, is using plasma and then and fields to hold it together.
So it's like lightning in a bottle. Oh, it is like lightning in a bottle.
That's cool.
Yeah.
I read something really cool about lightsabers, and I have to just mention this. Is that it says here, I'm reading this on an article about physics in Star Wars on Wikipedia. It says, since photons have momentum, those scattered photons from the lightsaber would exert radiation pressure on the hilt of another lightsaber if they were to clash. And the amount of energy needed to power, well, I'll get to that in a second. That an incredible, here it says, an incredible amount of energy is necessary to power such a lightsaber. For instance, powering a lightsaber with an electric field strength of 10 to the 15 volts per meter for 1 minute requires 10 to the 25 joules, or 10 times less than the total energy output of the sun in 1 second. And I know it seems 10 times less than the total output energy of the sun. I mean, we're saying it's less, but that's still an incredible amount of energy.
Dude, yeah, it's like the sun is huge.
So it then says if the energy source is nuclear fusion, such a lightsaber will require 10 to the 11 kilograms of nuclear fusion fuel to operate for just 1 minute. In other words, it would need to fit the equivalent of 10 Great Pyramids of Giza of nuclear fusion fuel in the hilt to operate such a lightsaber for just 1 minute. That's how much fuel.
Yeah, but what about antimatter? Like if we were to use matter antimatter, right? Like I think that I mean it's not a simple solution, because if it was a simple solution, we'd probably be using matter and antimatter as propulsion and stuff like that already. But
well, then that's my question for you, since you're what about antimatter?
Oh, that's my answer to you. Is that I feel like the way to get around it would be to do something to use something we don't have yet, which would be so. To be clear, we do have antimatter, and we have stored like a very small amount of it. Problem is, and the way that you store it is actually using magnetic fields, because if you use a magnetic field, it'll keep your antimatter cycling and cycling around in a circle. That's what you want to do, because the moment that it touches matter, it's gone, right? And so that's the issue, is how do you store a huge amount without it just annihilating with matter, without it touching. And so that's the issue, or the biggest problem right now. That kind of prevents us from being able to use something.
To be clear, is dark matter different from antimatter?
Yes, dark. Okay, so dark matter is actually exactly the same. Okay, dark matter is very much like regular matter, except that its fundamental interactions are very different. So it has mass just like ours, just like we do. But the reason why we have objects that are like that come together like little Grogu here, is because of all the forces that we have. So we have like strong force, which is what gives us atoms in the first place. So that's how you get an atom, is the strong force. The strong force holds quarks together to create like an atom, and then then to hold an atom and electrons in orbit around an atom. That's the electromagnetic force, and all these forces coming together are what can bring a macroscopic object like this together. So dark matter might not have, we don't know. We were trying to figure it out. It might not have all these complex forces. It might, for all we know. But it seems that it's more diffuse. So it doesn't come together into like sort of an object like this. Right? So it's just kind of like diffuse throughout the universe. So it's essentially regular. It's essentially like regular matter, but without the forces that it experiences. So without those interactions.
Okay.
So yeah. Yeah. Does that make sense?
Yeah. Thank you for
I did not know there was a difference before now, so thank you for that one. Let's see.
Yeah.
We are.
Go ahead, Gabe.
No, it's okay.
So
Go
did
ahead, Sarah.
anybody get the whole, like, when I googled lightsaber, I got like Star Wars and all this like confetti and all that stuff coming on my screen. That's why I told everybody to go.
I didn't get that. That's
Oh,
cool.
I didn't get that. I looked it up on my phone.
What?
Dang it.
Oh yeah, you had to look it up on your
Did you put a space between it?
No space.
I did not get a celebratory thing, but
No, what? Okay.
try it again later. But yeah, they previewed a lightsaber that's going to be part of one of their attracts, or the like new Star Wars hotel that will open next year. So,
The question is it going to be on sale?
Not currently. They say that it's mostly going to be used in like performances and like by cast members and characters.
Here, I'll send it in the chat just so you can see what I'm seeing.
Well, if only cast members can use it, I'm about to quit my job and go back to work at Disneyland.
Yeah, put that in the chat, and then I'll give it to other people who are interested in looking at it. I wanted to mention also something about the production of the film, the sound design.
What?
Yeah.
Oh wow. The sound of the lightsaber. There's a really great book that I'll put a link to called "The Sounds of Star Wars" by the sound designer of the films, Ben Burtt. And it's so interesting hearing all the stories about how they make the sound effects for some of these things. The lightsaber sound comes from the hum of a projector, the interlocking bits of a projector, and the sort of combined with the sound of TV interference to a microphone. Nowadays, that's not a thing, but back then that was a thing. TV is interfering with the signal of the microphone, so they're just moving the microphone around the TV to get that sort of what's it called? What is it? Doppler effect. And for blasters, the sound of the blaster comes from the hitting of the guy wires that are sort of there to help stabilize a freestanding object of an AM radio station. Ben Burtt was vacationing in the Poconos with his family, and he went to a guy wire in 1976, and he hit the guy wire, and he found that it sounded really cool, really close to the point of impact, and make this. So just by getting the microphone close to that, and then doing maybe a little bit of sound editing to cancel out maybe the bass frequencies, the blaster sound effect was born.
That's cool.
Now I want to go hit a wire myself.
Yeah. Hop a fence.
No. Do not try that at home. Do not try that at home.
Unless you know someone has access to an AM radio.
Here we are. For those of you who've seen Rogue One, if you have not, you should watch it because it's great.
I think it's the best Star Wars movie, but I'm partial.
Okay, if you want to start a fight, Sarah.
I thought it was really good too. I don't know if it's my favorite, but I really liked it a lot.
Yeah.
I love Rogue One. It was awesome. I mean, overall, I love all things Star Wars, but my favorite is Episode 5. That will always be my favorite Star Wars. There was just something about that scene, which I won't spoil, but you all know what scene I'm talking about. That just made me it just made me go, I love this, and just like I just like the shock and awe of the moment, that also like the execution of that story was just so good that it stayed with me forever. That's actually the scene I wrote about in my UC Irvine entrance essay.
Oh, that's okay, cool. Wow, that's awesome.
You're not alone.
Yeah, it must mean a lot to you.
You are not alone in thinking that one is the best one. That's generally considered the most critically acclaimed one. I think a lot of that has to do with not Ralph McQuarrie. Is it Ralph McQuarrie? Irving Kershner. Ralph McQuarrie is Ralph McQuarrie is
designer.
The concept designer for art. But Irving Kershner's directing is probably the most impressive of all the movies, because I have noticed that George Lucas is an amazing idea man and an amazing writer of concepts. Not the best dialogue writer and not the best director, as is evident in some of the movies that Star Wars movies and other movies that he's directed. Even this one, he directed this one, and the acting is noticeably different in Empire Strikes Back. The acting is, I feel like, is a lot more mature, and
Subjective.
it just seems a little bit more mature. I don't know. I mean, the characters obviously have matured as well, but the delivery of the lines is. Oh, sure. Yes, this is subjective, but like, I just read up a lot on it, and I've read a lot of different reviews, both contemporary and retrospective reviews of all the different movies, and I have to say that I kind of agree that Empire Strikes Back just stands out as having the most stellar performances. Because even if you go to the next movie directed by Richard Marquand, Richard Marquand was a lot more. He listened a lot more to George Lucas's input, whereas Irvin Kershner kind of struck it out on his own, which is one of the reasons why he wasn't hired back to direct Return of the Jedi. And that one just stands out. Empire Strikes Back just stands out. I don't know if it's my favorite. It might be my favorite. I like Return of the Jedi a lot too. So there you go.
I'm gonna try to change your mind. Because if you watch Star Wars Episode 3 in Spanish, in Espanol, oh my god. It completely changes the whole movie. It becomes this amazing telenovela in space, and it just blows your mind.
See, I was gonna mention those like episodes 1 through 3. I actually really liked them.
I love 1 through 3.
Well, Even though I realize the dialogue isn't the greatest.
Yeah, because there's different ways that you can enjoy a film. Do you know what I mean? Like,
yeah.
I'm not a critic, so I can enjoy the prequels. They have incredible nostalgia for me. I watched all 6 of them originally when I watched them as a kid, all of them. So I didn't watch them the old ones first, and then I'm at an age where I was the only one I could see in theaters at the time was Revenge of the Sith. That was the only one I was old enough to actually go and see in theaters. So the rest were all out on DVD, and VHS. But there are things that I can recognize that there are some shortcomings, and you can decide whether or not that matters to you when you're watching the film. It's all it's art.
We should have a ranking of like the best Star Wars movie by the science that's in them. I think.
Yeah.
A ranking for that.
By the science.
We should probably do that for ourselves.
How accurate it is, or how interesting it is by this, like how many concepts we can come up with that are unique to that movie, or
2 separate lists. I like that idea.
Right. Well, because I guess with the first one, A New Hope would always win because it introduced all the sneeze.
Oh, bless
all
you.
The space travel and lightsabers and the Force and everything. I know.
Hold on. This guy has the worst job on all of Yavin. Really. Quick.
I know, right? I wanted to mention before we get back to the science again that there is an interesting cut scene where we get to see Biggs Darklighter on Tatooine. But that was understandably cut. Where it's in the beginning of the film when Luke is at Tashi Station, probably getting some power converters or whatever, talking to Biggs Darklighter and another friend of his, Tank Sunbur, and they're looking up at the sky. They look up at the sky and they could see the battle raging on between the Blockade Runner and the Star Destroyer. I understand why it was cut. It kind of ruins the flow of the film. You want to see Luke for the first time when the droids find him. But
is that possible to like? I mean, we can see planes and ships.
There, we can talk about science with that.
Yeah. Like, how far can we see into space? I guess.
I mean, we can see the moon.
Into orbit. Yeah.
But it was during daytime. So it was during daytime. So it
you can see the moon during the day.
Yes, you can.
Yes, you can.
So it was the blasts in space were bright enough for that to be seen during the day. I mean, it wasn't particularly bright in the scene, but whatever. But with 2 suns, I mean, that's. Oh, I love that shot. Okay, where they're banking, and that. I was reading something today, the way that they turn. That they're made to look in this film like they're flying in an atmosphere where they would have to bank, and they would have to make this sort of turn. In space, you wouldn't have to do that at all, and that was purely done for aesthetic purposes because it looks cool. In fact, that was
okay with that one.
Flying.
That's one of those science parts where I was like,
yeah,
don't care.
Physicist Lawrence M. Krauss says this is for a simple reason: it looks good.
And they have enough oxygen in these.
It seems they do. One thing I did want to mention something. So like the reason why you can't see like stars and other objects and stuff like that other than the moon during the day is because we have an atmosphere. And so like if we didn't have an atmosphere, then I mean it would all be like the sky would be black, but you'd have like a giant star right there, which is our sun. And then so on Tatooine you'd have two. And then plus your other stars everywhere else.
Would you need stronger sunblock on Tatooine?
Yeah, probably, because the UV radiation there is going to be really bad.
Okay.
And hopefully their atmosphere is able to take care of a lot of it, because that's another thing that would be a really big problem.
I do remember that those two suns were like different colors. Like I wonder why that is happening, and then also like in binary star systems, you might not see both stars at the same time. Is that correct?
So okay, so let me address the first question, which was the colors, right? Depending on the mass of a star, it'll be a different color. The lower mass stars are more red, and then the higher mass stars get blue. So, and it's kind of funny because the colder, so the lower mass stars are also going to be less hot, so they're red, whereas the hotter ones get blue. And it's funny because on your tap, you have it in the reverse, where like hot is red and then blue is cold, but it's the opposite. And so you'll actually see that as well. So you have some star that's like around the mass of the sun, and then one that's like a lot less massive or in orbit around it. Then you have one that's like white or yellow, and then one that's red. So that's you see two different colors if they're different masses.
Okay.
But they would have to be different masses.
Mm-hmm.
The mass that determines like. Great. The second question, can you repeat it?
Like, would you always be able to see both suns or both stars, or does it depend on how it's orbiting?
Not necessarily, and I'll tell you why. It depends. So if you're in a system that orbits the pair, then yes, unless there's a really lucky orientation where which we have here, where one of the suns is behind the other, and you're kind of like you're seeing it like blocked. So that's one way that you would only see one. Another way that you might only see one star or one sun in your sky is if you are orbiting one of them, and so if you're orbiting, let's say, the main star, and then the other star is also orbiting around that same star. So there could be a point where daylight for you on the side that you're facing is like they could be on opposite sides. So then the other sun would be behind you. So like the other side of the planet, that not look like.
Cool. Yeah, I think that's really interesting for like what does day mean and what kind of life exists with these different kinds of sunlight patterns.
Like on. Oh, go ahead, Sophia.
No, I just wanted to just finish that thought. Like so if we did have a system like that, which is again it's with the stability of the orbit it's problematic, but like if we had a system where a planet was orbiting a main star and then the other star was kind of further out orbiting both, is that let's say you did have an orientation where like on one side you have one sun and the other side you have another, then the moment that you rotate the other way, you still have daylight. It's just it's a different kind of daylight. So let's say the other star is less massive, which is probably going to be the case, then it would be like a redder sky at that time, but you would have no night. So that would be a problem in terms of like how you clock. Well,
yeah.
I mean, like within the Star Wars canon, there's like the planet Ryloth, right? Which actually I don't know if this is canon anymore, but planet Ryloth is stuck in like an orbit. It's not anymore. Okay, whatever.
Yeah, well, I unfortunately.
In the original canon, Ryloth, where the Twi'leks are from, is stuck in orbit where one side is perpetually daylight and one side is perpetually night. But most life cannot exist on either of those sides, so they live constantly in the twilight zone, where it's day or like twilight 24/7, and all the creatures on there have adapted to that. Some live in caves and things like that, but they're completely adapted. They don't have a diurnal cycle. They completely live on that twilight zone. I mean, like here on Earth, we don't have continual daylight like year round, but there's some places that have daylight for like months on end, and the plants and animals. Yeah, the poles, like the plants and animals there have adapted to having that very odd diurnal cycle where it's like you have day for months and night for months on end.
Mm-hmm. And you can see though that like it's really cold in those regions, and so the problem would be that if you had something like facing, like facing like the sun all the time, and then one side facing the the opposite side, so it's always nighttime, is that it would get really cold because it never gets a chance to warm up, and then the other side would get extremely hot, and so and that would make life pretty hard. Yeah.
It's like, I need to go to this side so I can get a tan before I come back on this side.
Right, exactly. Let's go take a walk, get a tan, and then just come back.
Yeah, right?
Isn't it true? So that makes me think of like the moon is technically stuck in orbit relative to the Earth. Like we always see the same side of the moon. The moon itself is not spinning, correct? But then it still has it gets different parts of sun on it.
So the moon is actually spinning.
Okay.
It's still because like think about it, right? Because for the moon, it's orbiting around the Earth. So to us, it doesn't look like it, but it's moving like this, right? So that's still spinning on an axis. So although I can only see this side, it's still spinning. It's just that the way that it spins is tidally locked to Earth. So that, the moon would be like an example of a planet that was tidally locked to a star.
Tidally locked, that's the word.
That's the word.
Thank you. Thank you so much.
Pluto,
that was bothering me.
Yeah. Pluto and Charon or Charon, I don't know, whatever, pronounce it whichever way you like, its moon. Those two are also tidally locked.
Look at the X-wings just
bang. Oh, so cool.
Sorry, just the shot of the X-wings banking. It's all that World War II dogfighting. Someone put that in the comments. My friend Stefan mentioned World War II dogfighting. That's basically what they're supposed to be like. And George Lucas has done World War II movies. I saw a question a long time ago that was like, how can they turn if the thrusters always look like they're fixed?
Ooh.
Yeah, look, I mean, all the motion that happens here is just, it's unreal. Yeah. You literally need thrusters to change the direction.
Physics. Yeah.
So yeah, that's another thing where they just kind of just said whatever, let's go and do our own thing.
By the way,
you can't. So the answer to that is the question makes total sense because you can't without those thrusters.
Could you have like an individual control for each thruster to like change the orientation of the thruster, or like have that linked to like I want to turn left, I want all the thrusters to move this way?
Yeah, we do that when we send rockets out to space too. That's how like that's how you make adjustments, right? Because think about it, like if I'm sending something to Mars or whatever, right? I mean, to say that it's far doesn't even make sense. It's like it's incredibly far away, and so like yes, we calculate and we do really well and get ourselves there, but we do have to do adjustments. So it's called like an attitude adjustments and stuff like that, where you turn on like thrusters and kind of say adjust to the orbit. So yes, yeah.
Cool.
This is one of those examples again in Star Wars where you just have to let go and have it be believable and have fun with it.
Yeah, exactly. Just like the sand monologue.
Yeah. Oh my god, Reno, we're gonna get in a fight later. I swear.
I'm not like a prequel bachelor. I still like to watch them, and there's stuff that's cool about them. But
just kidding.
I think the cooler stuff about them was done in the novels and comics and in the Clone Wars TV show that the prequels made possible. The movies themselves, there's still some stupid stuff in there. I'm just gonna have to. I still enjoy it. It's just stupid, and I don't mean inaccurate. I mean like just like poorly written in my.
Yeah. I'm just joking. There's always gonna be dumb stuff, and these movies are not. This is Star Wars. This is not A+ artistic, deep, meaningful cinema. This is fun science fantasy.
No, this one did win an
Western.
Yes, it is.
Okay,
There's elements of Western. There's elements of it's a space fantasy.
I mean, he's heavily inspired by samurai as well.
Yes.
You know, Akira Kurosawa.
Yes, in fact, Akira Kurosawa, his stuff like influenced like the idea of having certain colors code who the good guys and the bad guys are. In all the Star Wars movies, the bad guys have like blue or green lasers, and the good guys have red ones. And the good guys always attack from the left, and the bad guys always attack from the right. But in the prequels, because the clone army eventually becomes the Galactic Empire army, even though they eventually phase out having clones, they have the blue and the droids have the red, and they attack from opposite sides. The clones attack from the right, from our perspective, and the droids attack from the by Death Star. We just missed the great shot, K1 in a million. Just interesting. Akira Kurosawa, like all those films have heavily influenced George Lucas.
Ooh. Wait, hold on, Sophia. In terms of like physics, right?
I was
when the
waiting
Death Star
for this.
explodes, right? Is that what it would look like? Would you see that kind of explosion?
Can you in terms of the physics?
Is that how it would look? Would you see that kind of explosion in space or no?
Yeah, so the ring explosion in the first place, that's a specific sort of I guess an explosion device or whatever, a weapon that we don't have. I don't think we have anything that explodes that way, but I'm not sure. Maybe somebody who's been in the military or is really aware of this stuff would be like, no, we do. But I don't think we do. But in terms of like, we just saw it literally kind of disintegrate.
Yeah.
Right. And then it just, we just saw these like little just light bits and stuff like that.
It like atomized. It didn't. There aren't even like chunks of it. It just disappeared.
Or like, is that similar to like how stars collide or explode in some way?
Yeah. So I'm trying to like we can actually address the stars question in 1 second.
Yeah.
But let me think, because like in order to explode something that big, you would need an immense amount of energy, which would heat things up to a point that's like out of this. That's bizarre. So I could see that kind of that would make sense. Whether it would look exactly like that, probably not. But the thing, like how it kind of just sort of disintegrates and like evaporates away. I think it could maybe not so fast, where it's kind of like just bam, like in an instant. But it does make sense, because you'd have to, like, things would heat up so much with that energy. Now, you asked me an interesting question. What was that? Like, we're two stars.
Like, does it, would it, like, because you said, like, oh, we don't have, like, a weapon that would cause that kind of explosion, but is it close in any way to, like, what happens when either stars collide or a star dies?
So when stars collide, so that's usually, it's not it's more of what happens in that case is, like, let's say you have a binary star system, and one of them is, there's a really cool word for it. It's not vampire, but it's something like that, because astronomers are just really brilliant at naming things. But it's like, it's not cannibalizing either. Cannibalizing is for galaxies. But so it's essentially like it's a star that's like eating off matter off of the other one. That would create a supernova. And yes, with a supernova, you would be able to explode anything. Like, so yeah. How you would make that happen though, like to actually just make it happen, there's nothing that exists that we can do that with right
that we would have that much control over.
Yeah.
Well, that comes to the end of our movie. That was really fun. Thank you so much, Sophia, for chatting with us and helping us learn so many cool things. I know I learned a ton.
Yeah.
Thank you so much for having me. It was fun.
Wait, I gotta get in one more trivia thing here.
Go for it.
The guy who plays Wedge Antilles, the only other person that survives this battle other than Luke, and who goes on to be in Return of the Jedi, the guy who plays Wedge Antilles is actually the uncle of Ewan McGregor, who ends up playing Obi-Wan Kenobi in the prequels. However, his voice sounds American because he's Scottish, and they dubbed over his voice with an American actor in both in New Hope and in Return of the Jedi.
Like James Earl Jones' voice is all dubbed too. He wasn't even in the Darth Vader suit.
Well, yeah, that's David Prowse. Because David Prowse is nice and big and tall. I just thought I'd mention that Wedge Antilles is one of my favorite characters, especially in the expanded universe, now called the Legends canon. Unfortunately, all of that is not canon, but that doesn't mean you can't read about it.
Yes, go and read those. Thrawn, the original
Rogue
Thrawn
Squadron
trilogy.
Thrawn trilogy, Rogue Squadron books, Wraith Squadron books. So good.
Jedi
so good.
Academy.
Come on. We could list these all day.
Yeah, we can go
Jedi
forever.
Order. Yeah.
Anyway, we've had a great time here. Sophia, thank you so much again. If anybody wants to like kind of follow you or learn more about your research or learn more from you, where's the best place for them to follow you on?
So I'm on TikTok, Twitter, Instagram. Twitter, I'm pretty active on, and as well as TikTok. I mean, you can find me on either of those. I'm at Astropartigirl on all of those. Yeah, I do have a blog site too. It hasn't been really updated as of recent, but eventually, like when I get my YouTube channel up, I'll probably be posting them over to there, it's literally just astroparticle.com. So yeah, on social media, and also I do have a page on Facebook, but I guess Twitter is my most active, as well as TikTok now, because I started using their cool video stuff. So yeah, that's
awesome. This is something I like to do personally. I have to ask like a lot of guest scientists, like for those of who might be watching, who might be interested in becoming a scientist, but their passions originally lie in science fiction and pop culture. What's a piece of advice you have for them to continue to pursue their passion in science, where they might feel bad about it or they might not feel smart enough about it?
Yeah, so that's part of actually what we're trying to work towards, is break those stereotypes where it's been made to appear as though like you have to be a specific type of person to do math or whatever. Look, man, I'm going to tell you this right now. A lot of people in the field are not particularly good at math, and they do this anyway. If you're passionate enough about this, just go through it. There's nothing that's going to be easy in life. But if this is something you're really passionate about, it will be so worth it. So that's my advice, is just go for it. Like, don't be afraid of the math, and don't think that you are alone. There are people who are very successful in the field who think that they're not good at math, or it wasn't their best subject as well.
Yeah. Thank you. Yeah, thank you so much for that. That's a great piece of advice. And as you saw here, there's a place for science in everybody's life, right? Whether you become a scientist or you just ask the big questions when you're watching your favorite movie like Star Wars. All of us here are scientists, but we're cosplayers too. We're just like regular people. As you saw, we don't know everything. So for those of you at home, if this is your way to get into science, this is your way to get into science, and embrace it and enjoy it. Thank you all so much for tuning in to our very first iteration, or first showing of Cosplay for Science Theater. If you want to follow us on our website, subscribe to our channel. This is a great way for you to meet scientists, learn more about science and your favorite fandoms, and get a chance to meet some really cool people and learn some cool things. Tune in later this month. We're going to do another Cosplay for Science Theater with some paleontologists as we watch the season premiere of Jurassic World Camp Cretaceous Season 3, and we can talk all about some really awesome dinosaurs. Thank you all so much. Make sure you like and subscribe, and we'll see you later this month. Bye, everybody.